Wilfried will be happy to take a little bit more time because he is an enterprise architect from one of the largest insurer in Switzerland, AXA. And Wilfried did presentations in our previous decision camps, and he goes right to the point, and he demonstrating real world application. And I really like his presentations previously, and I'm sure today he will show us he will share his modeling experience for different insurance products. And what is interesting is that he is doing this for many years using combinations of different tools. This is probably quite interesting approach when when insurance company commits not to one but multiple tools. Wilfried, take over.
Okay, thank you, Jacob. Yes, my name is Wilfried Kurth, and I've been working for AXA in Switzerland for 15 years. My major fields of activity are data modeling and decision modeling. And in 2013, we started with decision modeling based on the book, The Decision Model from Barbara von Halle and Larry Goldberg. But in 2016, we changed to decision model and notation. Today, I'm going to talk about our experience with modeling insurance products with DMN. So I want to introduce an approach we developed some time ago when we started to define a new household insurance product. The challenge was to provide a computable form of the written terms and conditions, and our goal was to use this for automated claims handling, for instance. While the idea of using decision tables to structure the terms and conditions is obvious, the use of decision tables is also limited to some extent. And using DMN relations to structure conditions, therefore, is less limited, but a little bit more challenging. And in the end, it will show that DMN is a powerful notation that enables business people to define almost all kind of decision logic. First, I would like to make you familiar with the example which I will use throughout the whole presentation. This is an extract of the terms and conditions of a household insurance product. And here we only focus on the part of the benefit promise. That is the part which describes the conditions for the compensation in case of loss.
Wilfried, sorry,
yes?
your slide's not moving.
Actually, you should see the page, the slide 3.
Oh, we can see only the first one.
I think you may have shared the wrong screen. If you put it into presenter mode, so if you unshare and then reshare and make sure you're selecting the right window to share, because you're only sharing the window that is the regular PowerPoint window.
Okay, I'm sorry.
Hey, we're all learning here.
So I try to share again. So let me know if you can see my presentation.
We can see slide 3, but we're seeing it in PowerPoint in your edit mode in PowerPoint, not in presentation mode.
Okay, thank you.
So if you if you unshare your screen, start the presentation, and then share and select the window that has the presentation in it.
What do you see now?
We're still seeing PowerPoint in your edit mode.
So again.
Let me stop your sharing, and then you can share again. Okay, there we go. We're seeing
This is
presentation.
okay?
Yes, we're seeing the presentation mode now and on slide 3.
Okay, thank you very much, and sorry for interrupting.
No problem.
Okay, here we only focus on the part of the benefit promise, that is the part which describes the conditions for the compensation in case of loss. Okay, I already told this. While continuous text is easy for us to process, it's not so easy for machine processing. And even automatic text analyzers could not help us properly, as such written insurance conditions are often incomplete and contradictory. So we first started with building a structured business vocabulary. Each section in the terms and conditions contained properties and according values. And now the statements you see are given in a shortened form. So Chapter 1 tells us something about insured object categories, usage and ownership. Chapter 2 defines the insured events, fire, well, natural forces, water, and so on. Chapter 3 defines the insured places at home and outwards. And Chapter 4 defines the insured sum in dependence on object category, safekeeping, and storage. Now that we have our structured vocabulary to describe insurance conditions, we need a form to represent them. As a next step, we choose a tabular form of representation for the insurance conditions. The column headers contain the properties, and each row with values describes a coverage statement from the terms and conditions. So the product module standard, for instance, includes an object category, household contents. And household contents is insured in case of fire, natural forces, etc. And the household contents is only insured for personal use. And there are no more constraints concerning ownership, place, storage, or safekeeping, and has a compensation up to the maximum of the insured sum. And there's the second row for the event simple theft of household contents at home with an insured sum, and additional an exclusion for simple theft outwards. And we have some more statements for money assets with some more restrictions. There are different compensations depending on safekeeping, and there are a lot of exclusions. So similar to a decision table, in an empty cell, none of the values is relevant, and in a cell with several values, these are valid alternatively. So this table describes the insurance conditions from the previous slide in a structured form. This is how we started with the new insurance product, but we had not yet come up with a method or a tool to apply the data in this structured form. One use case for structured terms and conditions is the automatic evaluation of benefit claims in the event of loss. And the tabular form of the terms and conditions already looked like a decision table with the claim data as input and the benefit promise as output. So our first approach was to provide the data as a decision table, and let us have a look first at the input data and the decision requirements diagram. So in a claim case, for instance, fire at home, there might be more than one damaged object, and each damaged object is described by several attributes needed to determine the possible compensation. And an insurance contract might include more than one insured product module. And each product module has its own maximum insured sum and deductible. So both the claim data and the contract data are needed as input data to decide the claim case. And now for each damaged object in this the decision benefit promise invokes a business knowledge model, determined benefit promise, which contains the decision table with the terms and condition. And now we can have a closer look at this decision table. So the content of the decision table is pretty similar to the content of the tabular representation we already discussed, with a few exceptions. So in order to address the correct insured product module, we must use the list contains function here in the first column. And to address the correct insurance sum, we must use a filter function here in the first output column. And to give you an idea how the decision table works, I provided some test data. We have a claim, a fire at home, and two loss objects in the object category household contents and the object category money assets. And the second input data is the contract with two product modules. There's a standard module and a bike module. And when we apply the input data to the decision, when there is a result with two conclusions, we have a compensation for money assets up to the maximum of 5,000, which is the limit according to the terms and conditions. And we have compensation for household contents up to the maximum of 250,000, which is the insured sum in the contract. So, so this approach might seem sufficient for the first moment, but if I want to know how my household contents are insured instead of what is the benefit promise in a case of fire, then this decision table is not sufficient anymore. And in fact, in 2016, AXA launched an app, AXA Sure, where you can check how your valuable objects are insured in case of all possible events at home or outwards. And our approach to provide the insurance statements in a computable form was based on the decision model method, and we needed 20 decision tables with about 360 rules. So a decision table containing terms and conditions works fine, but is limited to only answering one question. In this case, the question, what is the benefit promise in a given case of damage? The written insurance terms and conditions we are already being used for a wide range of use cases today. For example, when a new customer asks themselves which product modules they need for their new house, or when an insured person wonders whether their valuable watch is sufficiently insured, or then a customer needs to know which information all is needed to report a claim, then the written terms and conditions can already be used to answer these questions. If we want to use the terms and condition to answer a second question automatically, then we need a second decision. But because data and logic are together in the decision table, we needed to model the insurance conditions a second time, slightly modified. However, this does not seem to be very clever. We must find another way to depict the insurance conditions only once, to have them answered several different questions. The data in the tabular representation at the beginning of the terms and conditions are effectively constant. And in this case, it can be displayed better as a DMN relation. And here a business knowledge model contains the relation with the data of the terms and conditions. And with a new decision requirements diagram, the decision again has two inputs, the claim and the contract. And the second business knowledge model, determine benefit promise, that contains the logic to be applied on the relation. And to describe the decision logic, we use a context, and with two context entries. One to read, or the first to read the data of the relation, and the second with a filter expression comparable to SQL, structured query language, to filter the matching row of the relation. And we have a context result that gives back the searched insurance statements. And now decision logic and the data describing the terms and conditions are separated. So let us have a closer look at the relation and the simulation with test data. So now the DMN relation is pretty much the same as the tabular representation in the beginning, and there's no need for functions, and the syntax is slightly different in contrast with the decision tables. So now we have the same claim and contract data as in the previous simulation for the decision table, and the result now is different. Unlike a decision table, we get now the whole row of the relation and not only the output columns. So DMN provides all the means needed to model the terms and conditions of insurance products, and DMN provides all the means to model the logic needed to apply on the modeled terms and conditions. So with DMN, we are able to provide computable insurance products. So this is a second use case. And in this use case, we want to determine the required information to report a claim. This is the same relation and business knowledge model as from the slide before, so we can reuse them. And now the decision logic and the data describing the terms and conditions are separated. We can easily model a second business knowledge model, determine attributes and values, which contains the logic to be applied to the relation. Again, the business knowledge model consists of a context with two context entries, but no context result. And the first context entry determines the attributes, and the second context entry determines the corresponding values of the attribute. And again, there is a decision which invokes the business knowledge model containing the logic. If we simulate the decision, the result has two lists. First, a property list containing the properties, and second, a value list containing the possible data for each property. So why is such a use case relevant? Imagine another type of insurance product, motor vehicles insurance, for instance. If you had to report a claim for your car, you have to provide other information. The event might be a collision or vandalism, the damaged object might be the windshield or an exterior mirror, and so on. The terms and conditions can be used to automatically extract the information needed to report a claim. So DMN helps us to provide all the business logic needed to run the business. So this logic must also be made available in the business processes. And imagine a claim process. And here we have our decisions and business knowledge model provided by business analysts and maybe provided by product engineers. And if the customer must report a claim, they first choose the line of business. The line of business is handed over to the insurer, and now the insurer starts the process to handle the claim. And the first task is to determine the needed information to report the household claim. So the task executes the decision, and the result is handed over to the customer. And now the customer describes the household claim according to the requested information. The claim report is handed over again to the insurer, and the next decision is executed by the task determine benefit promise. And if the customer is eligible for any compensation, another decision is executed and the result is handed over to the customer again. So BPMN, like DMN, is a notation for the business. And these two notations together enable the business to describe all the needed business logic, that is, processes and decisions in an executable way. In addition, the decisions can be simulated with taste data. And unlike requirements in written form, the business analyst can ensure that the modeled decisions are executable and also functional correct. There is a need for structured computable insurance conditions today, and often currently used systems do not yet offer these capabilities. But instead of writing requirements for missing functions and implementing them, you better model decision logic with DMN. However, a few systems on the market already do provide these capabilities. But if you replace a system, then you run the risk of not having all the decision logic the business needs. Here again, you are better off using decision logic with DMN. Modeling processes and decisions are a better way to get system up and running quickly. And as a closing statement, BPMN plus DMN means agile business. Thank you.
Thank you, Wilfried. That was great. We have a few questions in the Slack channel. Jan Van Tannen says he would say that they made a comment that the decision logic or the table could be the same, but that the reasoning or inference is different. I'm not sure specifically what that was in reference to. If you'd like to unmute yourself, you could maybe clarify.
All right, I should be unmuted.
Yep.
Yeah. My colleagues from the same university and also one of the other papers here are dealing with inferencing on logic, which is described using DMN. And what they show is that there are multiple possibilities to do optimization, what-if questions, and so on, basically used on the same logic, sometimes more than a decision table, but anyway, the logic and the inferencing are two different things. And that's basically what you're saying, if I understood it well. And if not, I'm sorry.
Okay, I think we both mean the same.
Okay.
Okay, Alan Fish also just had a comment. He said just to thanks for focusing on the DMN relation. He said it's a much neglected feature and it solves a lot of problems which decision tables can't.
Okay, yeah, it took me some time to figure it out on my own.
And Matteo commented that he really likes slide 9 with seeing BPMN and DMN in action from a real practitioner's use case. And I like that as well, because I come more from the process side, but end up with a lot of BPMN diagrams and how they fit together with things like the decision tables or decision steps.
Okay, yeah. Thank you.
Good. All right. Well, we don't have, Jan Purchase has a question. He said, how far are we from using models like this to broker products?
Oh, I'm not familiar with that.
Jan, you can clarify.
He said that having one insurance company define products for another.
Yeah, this is an important subject for AXA too, but we didn't focus on that currently.
Right. And he was using the example of a bespoke insurer using a bigger one to market and execute products. And, you know, definitely there's so much going on in the insurance industry right now with these smaller players, these online only players and insurtech firms and so on. So I think that that's going to be an important thing. Mark Woods made the comment that he sees a possibility for this in reinsurance, especially with life insurance companies. Were you looking primarily at the property and casualty insurance, or were you looking at life insurance as well?
At AXA, we are actually not looking at the life insurance. There's a different approach, and so my focus is also more P&C.
Okay, all right.
What actual products do you use now for BPM, DMN?
For modeling or for execution?
In general, all products. I know that you're using combinations, but what is the combination today?
Also, the product we are using for modeling is the Innovator from the company MID in Nuremberg, and for decision execution, that we right now using Drules.
Okay.
Okay, good. Well, if there's no more questions, then we will finish this off and we will get ready for our next presentation.
Okay.
Thank you.
Thank you very much.